Alright, so I picked this thing up in a surplus store, one of my favourite surplus stores in Akihabara. It's a Tokyo Rickshaw. Rico slide trans, a slide transformer is what that means. It's just a Variac. Turn it around, it's got a coil of wire inside around a former, around the core, and then you've got a carbon little brush that goes around, kind of like a variable resistor potentiometer, that kind of a mechanical arrangement, except it's not a carbon trace, it's a winding, and it's a variable transformer, so you AC in, AC out, and you can dial in exactly what you want. But as you can see, it's a little bit worn, a little bit old, paint's a little bit how you're doing, and on the front it's a little bit limited. You see we've got input and output terminals. You see the line there to indicate that they're connected together. But yeah, so when I want to use this thing, I've got to kind of just stick wires in there, tighten them down. It's a little bit how you're doing, a little bit not as safe as I would like. So I want to replace this whole front section with a new thing, which I have 3D printed in advance. A new enclosure. Look at that, straight off the printer, no post-processing whatsoever. Just knock out the supports are in there and just pull out a little bit of the there's a tiny little bit of stringing inside, but apart from that, whoa, that's print on my Wanhao D6 Duplicator 6, which if you look in my history you'll see a few videos on that, but I have got that dialed in beautifully. I'm really happy with that. So that's going to sit on the front and replace that one. Oh, just like that. Actually, it's going to go that way. So what are the holes for? Well, I'm going to put one of these in. This is a what part number? It's a JEC brand, JR-101-1 FRS. Just a IEC fuse holder power switch. You can buy these from, I think, Mouser or Allied or RS Components or whatever. So that sits there like that. That's my power in and power switch and a protective fuse. So that's going to help keep it all safe. Easy to plug in any sort of IEC connected cable, C13 or whatever. And then on the output, we got one of these. This is a, what is this? Jet brand, JET, I think that might be Japanese. And it is an AC-G07. And that clips into there like that, beautiful. And see the little clips, got little recesses for them and everything. Thought of everything. And these two holes, well, I got some binding posts. So these, I got a red and black one. Sit in there like that. On the back. Oh, if I can get the washers the right way around. And basically give me access. So if I do want to hook wires up or banana jacks or whatever, I can, and I can also easily connect my my multimeter so I can dial in a perfect voltage what I want to come out here. So that, I think, is going to work quite well. I have a little label in there saying danger, high voltage, don't touch it, not to be operated by idiots, that sort of thing. So that's the box that's going to go on the front. I've got some nice new stainless steel screws as well. Design there, nice and flush, beautiful. So that's going to bolt to the front and replace these nasty old screw down terminals. Ugh. And also, as for the enclosure itself, you can see the coils there inside. As for the enclosure itself, I'm going to strip that back and give it a coat of hammer finish paint, sorry. So some like grey, I can't remember the brand, grey hammer finish style paint. I was a bit worried about these handles because I'm like, oh, looking at these, and they're welded, spot welded on, but it turns out, on closer inspection, it seems the stops are actually Phillips screws. So let's see if I can, yes, I can take them out, which is fantastic because, whoop, that's going to make it very much easier to paint. I can pull that out. There we go, look at that. And that looks like it was meant to be chromed in the past. That was chrome plated. I wonder if that's a standard size. I might be able to find a new part for that. If not, I wonder if it's even worth chrome plating it again. Might have to think about that one. Because it would be nice to have that all nice and original. Nice chrome handles. And that will be all painted. So I'll tear this down. I've already, in the past, I've already replaced the brush. I contacted the company, fingers crossed, wishing upon a star that they still had parts, and they said, yes, we can send you brushes, 2 for $5 plus shipping, so about $10 or something. I got 2 spare brushes, so one of those is in there now, and the other one is being kept spare. So it does work quite well. The old brush was very much worn down. So I'll take this apart. We'll have a look inside. I'll show you how the thing actually works. Okay, so I've got all the screws undone. Take the knob off. Nice Bakelite knob. There's a label. You can see there. All dirty and gross. Nice and clean. And if we take the top off, that is our mechanism inside. So basically what we've got is we have one wire here comes in, and there's our at our 0 point. So if we turn that all the way around, the brush is right up at the end here. So we coming in here, yep. Then the windings wind all the way around to here, and we've got a screw here. We could put a terminal on there, but if we do that, it'd only be 0 to 100 volts. The tap for the other side of the input, so that's the active and neutral, is actually tapped in right around here. So if we look at the label, it will probably say 100 volts is about there somewhere. Yep. So like that, 100 volts is right there. That's right where the tap is. So with a auto transformer or a Variac, when you go past the tap point, it starts increasing the voltage. So you go from 0 to your input voltage to where the tap is, go further, and you get more and more voltage. So if that tap was around here, it'll be 0 to 100 volts with a nice fine resolution. But in this one, the tap's around the back here, so it's not quite as much resolution, but we get the full 240 volts, which is good because I need that for testing various things. And then the output comes up through the brush. You see this kind of tab thing here, and then that comes out to the output, and the output is tied to the input here, so it's not an isolating transformer at all, just for adjusting voltage. So if you wanted this to be an isolated system, you'd have the isolating transformer before or after. I don't know if it matters, but anyway, you have to have a separate isolating transformer. So if I tip this up, oh man, you can see there's our brush. I'll zoom in a little bit. So that's just a little thing there, 2 screws, and then this whole section comes out with the carbon in there. That's what rides along and gives us our contact. Nice and smooth with the graphite there, and it's about, I guess 10 mil deep, 10 mil down. So it's got a good amount of width there to pass a good amount of current. This will output maximum 10 amps or 2 kilovolt amps, 2 kVA at maximum of 10 amps. So it's a good size for testing things on the bench. So my next step is to take this out of the base, take the transformer section out of the base, and I guess we can start looking at the wiring here. But got to take this out so we can strip all the paint, give it a new coat of paint, and make it look shiny again. So it turns out my neighbour has a sandblaster, so I was able to sandblast the old paint off of these parts. And then I gave them a nice thick coat of hammer finish paint, and they have come up beautifully. Look at that. Not a single run anywhere. Quite proud of myself with that. So that's looking really, really, really good. So that's the painting part done. There's only one other hard part, and that's the top label. But I've got an idea for that, so we'll come to that near the end. The next step now is to start putting all this back together and get it assembled. So I've got the transformer core to sit in there, and on the front we're going to put the 3D printed box with all the controls and stuff. Alright, so let's see if I can remember how this thing goes back together. So I've got a bit of plastic and a bit of insulating cardboard-ish stuff, and another bit of plastic, and each one of those goes like that. 1, 2, and 3. Then our transformer, oh, I've got to get this angled the right way around. 1, 2, 1, 2, that way. So this core, oh, goes there, like that. Just there. Looking good. Then we have the bit of paper stuff there. There's a bit of plastic, hang on. Bit of plastic. And then that one goes there. And then we got this, which goes up its bum. And sticks out the top, and then this one goes on there. To hold it all together. Alright, I'll do that just finger tight for now. Oh, I may as well tighten it up, I guess. That'll do. Don't want to go too tight, don't want to damage the windings. And then this, how does this go? I think that sits one way or the, no, it sits that way. Then we've got a brass bit. We've also got a connection. This one sits there. That's my control box. Yeah, that's got a screw there, so that screw there's got to come out. Like that. And then we've got the brass thingy. I've got a springy washer. Where does that go? Not there. Oh, it goes underneath there. Okay, so it goes like that. Yeah. And this one goes on. Like that. And bag of bits, and I've got a circlip. All the screws and stuff. So we've got a circlip. Oh, if I can pick it up. And that goes here. Oh, that needs to be squished. Alright. Man, it's so heavy. Looking pretty good. Alright, so I've got my white wire here. It's got to go to the white wire there. I've got the black one here. It's got to connect into the, where is it? The neutral side of the switch. So that goes down in there. I've got my little schematic here. So we've got the neutral and active coming in from the IEC socket here. We've got the earth going down to the chassis. Comes through a 2-pole switch. So the black on the transformer, that is that one there, which taps around to here, around the back. And we come up through the outlet and then to the front panel connections, the binding posts. So that's the wiper on the transformer, that's connected. That's that one. The white on the transformer, that we've got to connect to there, and then that's our ground to the or our earth connection. It's got to go to the chassis, and that connection is just there. So that's going to be hidden inside. The box is wide enough to go over the top of that, so there's not going to be any exposed connections, any exposed wires or anything. So what I'm going to do, I might snip that off and then put a crimp lug on there and screw that down onto there. So I've been thinking about how I'm actually going to do this front dial face, how I'm going to make that, and the handles. Like I said before, I don't really have a workshop that I can do metalworking, that sort of stuff, in just the electronics workbench here. So it's going to be a little bit difficult. Then I had a thought. Why don't I just send an email to Tokyo Rickshaw, the company that makes this thing, and see if they sell spare parts, because they do sell the brush. A few years ago when I first picked this thing up, I got a new, two new brushes for in here. I got one, and then I got another spare just in case I need it later on down the road. And you know, by that time maybe they don't sell them anymore. So I got the spare. So I sent an email, and they sent me a new dial and 2 new handles. Look at that, nice and shiny, easy peasy. Cost me about I don't know what it was, about 3,000. No, less than that, 2,500. 2,500, 3,000 yen, so about 25 bucks. 25 bucks for the 2 handles. And a brand new dial face. Beautiful. There is one change I need to make to this, because this is actually a modified unit. It says the input is 200 volts. I've got to change that to 100 volts. So I might just print a little label and stick it on there. Output is still 0 to 240, but this originally was a 200 volt input, 0 to 240 volt output, but the wire's been soldered around on the end there, and it's now a 100 volt input, which is a lot more useful in Japan here. So what I will do, I will get my screwdriver and we'll put this thing on. And get that finished. One, two. This has the benefit that I don't have to mess around trying to figure things out and pulling my hair out trying to make it look professional and nice. It's actually original. I've had good experience with Tokyo Rickshaw. Tokyo Rickshaw. They seem to be quite forthcoming with parts and information. This one, okay, so I want to turn that. Oh, where's my pliers? I'll just tweak that up a little bit. Put it to 0. We'll turn that around. Oh, we've gone too far. Put it back to 0. What about there? Where are the holes? Right there and there. Like that. Turn that to 240. Perfect. Back to 0. Perfect. Let's tweak them up. Nice and tight. Tight like a tiger. Beautiful. Now, I don't know what the serial number used to be. It's completely gone. It wasn't stamped, it looks like. It should be right there. Can't even see it. I think it must have been written on there. But that's alright. I don't really care. A couple screws. I've got new screws for the handles here. They didn't supply screws. I must have to have purchased them separately, but that's alright because I already have nice new stainless steel ones. And then we'll be done. Oh, so heavy. Oh. These ones go on the ends. Two, number 3, and last one. Whoop. And with that, we are finished. Beautiful. Oh yeah. Handles make it a bit easier. That is fantastic. I am happy with that. I am a happy chappy. Alright, well, let's try it out. See if we don't blow something up. I'll plug the power in and plug a multimeter in, and we'll see what voltage we get out. So we have our power coming in here, power coming back out to the multimeter, and of course if we wanted to we can plug something in there, but nothing there for now. If we turn that on, lights up red to let us know that we're turned on, and it's at 0, but we've got 1.3 volts, but that's just like a floating voltage. If I put any load on that, it's going to go back down to 0. And if we go ahead and turn this up, that should be around 40 volts. Yeah, 39.7, that's pretty much spot on. Let's go to 80 volts. Around about there somewhere. Pretty much spot on. Let's go to 100. So that's pointing to where the incoming line has been connected to the transformer in there. If we connect it around somewhere else, we can get different voltages, like input voltages, but we've got it connected there, so that's 1-to-1 at the moment. If we go up to 140, pretty good. I can run American stuff if I want to run at the rated voltage. Let's go to 200. If I dial that down so the meter says 200, a little bit low, but that's alright because once we load it up the voltage will drop down a little bit. It's because open circuit's going to be higher. If you go right up to 240, 243 volts. That's looking really good. I am happy. So that is done. That's actually finished. I'll turn that off before I go poking around and unplug it. I want to be able to use it before I electrocute myself. So yeah, that is a fully restored and upgraded 0 to 240 volt output, 100 volt input Variac auto transformer. Beautiful. 2 enthusiastic thumbs up for me, and I hope you enjoyed that video. We'll see you in the next one.